This is Algebra 1 Keystone Exam Review Part 2. Today we're going to talk about inequalities. So just as a quick reminder, these are our inequality symbols. There's a less than, a greater than, a less than or equal to, a greater than or equal to. And somehow you have to memorize those. Some people say, hey, a less than looks sort of like a squished L, or maybe it points to the smaller one, but somehow if you could please remember those. And we're going to solve an inequality pretty much the same way we solve an equation. So let's go ahead and do that. 3x minus 9 is greater than or equal to 6. So we want to use the reverse order of operations. Please excuse my dear Aunt Sally. So we're going to get rid of addition subtraction first. So to get rid of the minus 9, we're going to add 9 to both sides. And then we're going to get rid of multiplication and division, so we're going to divide each side by 3. So it looks like x is going to be greater than or equal to 5, and there it is. C is our correct choice. Now you know what's coming. There's an exception. When you multiply or divide by a negative number in an inequality, you do have to flip the sign. So as soon as I realize I'm multiplying or dividing by a negative number, I'm flipping that sign so I don't forget. So let's go ahead and practice this one. We have negative y over 5 plus 6 is greater than 2. So again, we're going to get rid of that addition subtraction first. So I'm going to subtract 6 from each side of the inequality. So I get negative y over 5 is greater than negative 4. I'm going to get rid of that divide by 5, and I'm going to get rid of that negative sign while I'm at it. So I'm going to multiply both sides by negative 5 to get rid of the negative. Negative divided by times a negative is going to give me a positive. So I'm going to go ahead and multiply both sides by negative 5. As soon as I see I'm multiplying by a negative number, I'm going to flip that sign so I don't forget. And I get y is less than now 20. And so our answer, it looks like it's going to be letter B, y is less than 20. They're counting on you forgetting to flip your sign, so they're going to throw a greater than symbol in there. Let's keep going. All right, then we're going to graph it. And remember, if it has a bar, you want a closed circle. If it doesn't have a bar, that means it's an open circle. That means the number is not a solution to your inequality. So we're going to do the same thing. We have 9 minus 2x is greater than or equal to 1. Let's get rid of that 9. Don't look behind it. That minus or negative goes to the 2, not the 9. It's a positive 9, so to get rid of it, I'm going to subtract. I'm going to get rid of addition subtraction first. And then that's going to give me negative 8. Now I'm going to get rid of that negative 2, so I'm going to divide each side by negative 2. Boom. As soon as I see I'm dividing by a negative, I'm flipping that sign so I don't forget. And then negative 8 divided by negative 2 gives me positive 4. All right, so it has a bar, so we know it's a closed circle. They all have closed circles. This one's on 4, 4. This is 5, 5. So right away I know C and D are wrong. And I want less than, so I want shade down. So it looks like A is going to be our correct answer. All right, let's turn it into a word problem. It says Max brought $20 to the arcade. So that means he's allowed to spend his $20, but he can't spend more than his $20. So that means he's allowed to spend less than or equal to $20. It says he's going to spend $6.50 on snacks, sure, and then each arcade game costs $1.25. Okay, so we'll just call it G for games, okay? That'll be the number of games he's playing. So it's $1.25 per game, plus he's spending $6.50 on snacks. And remember, he cannot spend more than his $20. It's okay if he spends less and comes home with some change, or if he spends the whole $20. So it's less than or equal to the $20. So here we go again. We're going to subtract the $6.50 from both sides. So I'm going to take $20 minus his $6.50 that he spent on snacks. So we have 1.25 G is less than or equal to $13.50. Okay, that's what he has left for games, and we're going to divide each side by 1.25. And so the number of games he can play and I get 10.8. Okay, so it has to be less than or equal to 10.8. You know you can't play 10.8 games. So it says Max can play 11 games. Nope, he doesn't have quite enough money for 11 games, so we know that's wrong. At most 10 games, yep, that looks good. At least 10 games, nope. At least means he can play 10, 11, 12. He doesn't have enough money for that. And Matt can play 10 games, but this number is neither the most nor the least. He can play less than 10 games. He can come home with some money, so that's okay. So we're going to go with B. Max can play at most 10 games. Okay, so that means less than or equal to 10 games. All right, now we're going to graph it on a coordinate plane. So they graph the line for us, and we know if it has a bar, that the points on the line are also included in our solution set. If it doesn't have a bar, that means the line itself is not a solution, and that's when we need to dash it. So this is a solid line, so I know it's going to have a bar. So right away I know A and C are incorrect because they don't have the bar. We're shading below the line. When you shade below the line, that means it's a less than. So I know D is my answer. If you shade above the line, it's points greater than. So we shaded below, so I knew I wanted a less than or equal to. Okay. Now let's go ahead and graph two lines. So the first one's in slope-intercept form. So I'm going to start with that one, and maybe we don't even have to do the second one. We'll find out. So it looks like I need a line that's going to hit the y-axis at -3, and that's my y-intercept, and that's going to be a solid line because it has the bar there. So let's see if we can eliminate any answers. I'm looking for a solid line going through -3. And it looks like all four of them have a solid line going through -3. So the next thing I look at is my slope. I have a slope of +2, which means we rise 2, run 1. So from the -3, I rise 2, run 1. You can see this line is messed up, so I know A is wrong. Now I'm going to go to B. I'm going to rise 2, run 1. This one is also messed up. It should be right here, and it's not, so we're going to get rid of B. From C, I rise 2, run 1. Okay, this one's looking pretty good. Rise 2, run 1. So that one works. Let's see if this last one does. Rise 2, run 1. So this one's okay too. So we know it's either C or D. So let's see if we have another clue we can look at. Then it says it's greater than, so we need greater than means above the line. Do you see how C is not shaded above the line? It's shaded below the line, so that's a problem. And so we go back to my line again, and it's shaded above the line, so I know D is my solution. I didn't even have to look at my second inequality. Okay, let's try a word problem. Tony has $200 to buy pants and shirts. So that means he can spend all $200, but he can't spend more than. So we know he wants to spend less than or equal to his $200. It says he's going to buy no more than 8 items. So he can buy 8 items, but he doesn't want to go over that. So we're going to say X plus Y, his shirts plus his pants. Oops, X are pants. His pants plus his shirts have to be less than 8 items. And we're told that pants are $35 a pair, shirts are $20 a pair, and when we get up to the register, we better spend less than or equal to that $200. So which of the following statements is true? I'm going to go with the easy one first. Did he buy more than 8 items? So 2 plus 6 is 8. We're okay there. 4 plus 4 is 8. That one's okay. 5 plus 3 is 8. And 2 plus 6 is 8. So that one didn't help us much. So we're going to have to move on to the next one. So it says if he buys 2 pairs of pants, so I'm going to say 2 times 35, so that means he's spending $70. He can buy up to 6 shirts. Okay, so let's subtract 70 from that. So that means we have $130 left over, and each shirt costs $20. So 6 times 20, let's see how much money that's going to cost us, is $120. Okay, that one's going to work. He can buy, that one's possible. Let's just check the other ones. If he buys 4 pairs of pants, that's $140. He can buy no more than 4 shirts. Okay, so if he spends $140 on pants, that means he has $60 left over, and shirts cost $20 a piece. I don't think he can buy 4. 4 are going to be $80, so we know this one's out. If he buys 5 shirts, okay, that's $100. He can buy 3 pairs of pants, up to 3 pairs of pants. It looks like he has $100 left over, and each pair of pants is $35, so 3 pairs of them would be $105. He's going to be $5 short when he gets to the register. And just to check the last one, if he buys 2 shirts, that means he's spending $40. That means he has $160 left over. He can buy at most 6 pairs of pants. So at $35 a pair, $35 times 6, that's $210. 35 times 6 is $210. We don't have $210. He only has $160 left, so I know that one's wrong too, okay? We should have gone with our first instinct. The first one works for us. Please try the practice problems. Let me know if you have any questions. Thank you.